Friends, we will continue with the module 1 lectures on safety assurance and assessment. Now we are on the lecture 10, which will discuss about hazard classification. We will try to recollect some terminologies which you understood earlier. Hazard is a chemical or a physical condition that has potential to cause damage to people, property or environment, whereas incident is the loss of contamination of material or energy. All incidents do not propagate to accidents. Hazard analysis is therefore a system or a scheme which represents identification of undesired events that lead to realization of a hazard. Hazard is a scenario. Analysis of the mechanisms by which these undesired events could occur will be a focus in hazard analysis. Estimation of the extent of hazard, magnitude and likelihood of any harmful effects will be all as a focus of hazard analysis. Let us quickly understand the comparison between hazard and risk. Hazard is a scenario. It is nothing but a situation resulting in more likelihood of an incident, whereas risk is realization of a hazard. The incident becomes an accident and therefore it becomes risk. Let us talk about hazard identification. Hazard identification deals with assessment of engineering failure. It evaluates reliability of specific segments of a plant in operation. It is useful to determine the probabilistic results of failure. Interestingly, hazard identification is generally done on plants which are in operation. Fault tree analysis is also another common form of failure assessment, which we will discuss later. Hazards are common in process industries. We all know that because it is a scenario, which is a condition which can be always prevalent in any process industry. Of course, oil and gas industry is no exemption. It is essential to identify hazards if one really wants to reduce the risk involved in a plant process. Unfortunately, they are not identified until an accident occurs. Therefore, certain frequently asked questions should be there to make hazard identification an important parameter. What are hazards? What can go wrong and how? What are the chances of they going wrong? What are the consequences if they go wrong? What are hazards will give you a result as hazard identification study. What can go wrong and how will tell you risk assessment, which will include focus on probability of failure. What are the chances is determined by frequency of occurrence of the accidents. What are the consequences will tell you or lead towards financing risk, which you understood in the earlier lectures of the same module. Hazard identification and risk assessment combined together is called as hazard evaluation. Risk assessment is also a part of hazard analysis. Let us quickly talk about the flow sheet of an hazard analysis. We should identify the system first, what we call a system description. Then based on the system description, we must identify the hazards present in the system. Based on the hazards present in the system, we should be able to identify the scenario present in that system, which will lead to two issues parallelly. One is called accident probability, other is called accident consequence. We all know that the product of probability of occurrence and the consequence of failure together gives me risk analysis or risk management. So, scenario identification will branch out into two. One is talking about the evaluation of probability of accident occurrence, and the second could be if they occur, what would be the consequence. Both of them together will lead to risk determination. Risk or hazard acceptance level will be anyway established for a given industry, because there is a decision box here. Every industry will have their own standards of risk acceptance levels, which is suggested by Oil and Gas Industry Directorate. So, you must check whether the determined risk from your system identification is acceptable to your plant level. If it is accepted, go proceed and build and operate the system. If it is not accepted, modify either the process or the plant operation, or prepare for emergency response, otherwise meaning for safety. So, get back to the system description again after the modification is done and follow the same process until your process or the description of the system reaches acceptable hazard level or risk level as suggested by the Oil Safety Directorate. Hazard evaluation can be performed at any stage in a plant. It can be performed during the initial design stage of the plant itself, because we already seen in certain examples where safety can be done even in the design stage itself. One classical example which is attempted in industry is FMEA. FMEA stands for failure mode effect analysis. This is one of the very powerful mechanical tool which is used for initial design stage to do hazard evaluation. Hazard evaluation can also be done in a plant during ongoing operation. Example is HaZOP study. If the hazard evaluation shows low probability and minimum consequence, then the system is slated as gold plated system. Unfortunately, you must understand that gold plated system always have potentially unnecessary and expensive safety equipments and procedures in place which are implemented in the system. So, the system otherwise becomes very expensive to maintain a system to remain as gold plated. Let us ask a question now, what is an important step in hazard evaluation? The most important step in hazard evaluation is to establish the acceptable level of risk. The level of risk acceptance is highly subjective to each organization. Therefore, it is very important that your organization should predefine the acceptable level of risk. But there are also standard procedures to define or to determine the level of acceptance of risk level in a given plant. There are different methods of hazard identification. Process hazard checklist is one amongst them, which deals with listing of items and possible problems in the process that must be checked frequently. The second method is hazard surveys. Hazard surveys deal with checking inventory of hazardous material. The third study is HaZOP study, hazard and operability studies, which are carried out to identify the possible hazards in a process plant which is in operation. The fourth could be a safety review program, which is a less formal type of HaZOP study. This can result on experience of a person. Therefore, the views or the recommendations made by the safety review program dependent on the experience of the person who is conducting the review program. There are other parallel methods for doing hazard identification. The one which is topmost in the list is what if analysis. It is a less formal method. It applies what if logic to a number of investigations. For example, the question shall be, what if the power stops? So, you identify the consequences of failure because of stoppage of power and identify the hazards leading to the scenario. Therefore, what if analysis is a less formal type which is a result of series of questions asked based upon the process or the industry available. The result of such questions will definitely yield to a list of potential consequences and how to solve such problems. The second in the list is human error analysis. This method is used to identify the parts and procedures of a given process plant. Generally, it is applied to the process that has higher probability of human error. For example, failure of fire alarm system, failure of buzzer system in a control panel, which will have a higher probability of human error, generally is conducted under this kind of survey or human error analysis. The third one is of course the most important one, is an hazard identification, which is FMECA, failure mode, effects and criticality of such analysis is FMECA. This is a highly formal method which tabulates a list of equipments in a given process. It also finds out the possible failure modes of each item present in the process plant, and the effect of particular failure is considered with respect to the process as a whole. So, this gives me a detailed diagnosis of failure in fact in the component level as well as in the product level as well. Let us open out the discussion on HaZOP study. HaZOP expands for hazard identification during operation. So, the OP stands for the operation and HAZ stands for the hazard identification. What is the main purpose of conducting an HaZOP study? There exist always deviations from a design intent. Now, one will get confused with these two terms newly introduced now on the slide. What is a deviation? What is a design intent? I will give classical examples to make you to understand what are these terms referring to. This is applicable to an existing or to a new plants as well. You can do a HaZOP study for a plant which is in operation or a plant which is already prepared for operation but not at commission. So, it is in design stage. The main purpose of HaZOP is to identify the potential hazards present and the operability problems which occur due to any deviation in a given plant. Now, the emphasis of HaZOP study, dear friends, is based upon only identifying the deviations of a given plant. The deviations can either occur during the design stage or can occur even during the operational stage. Hazards can arise due to deviations from a normal process. HaZOP study therefore gives insight to these hazards that arise during the operational problems in a given process plant. What does HaZOP analysis provide me? It identifies all possible hazards, it identifies all possible operational problems, it recommends changes and further detailed studies required if the process correction need to be made for a given plant. Now, the fundamental question asked, apart from not understanding the differences between deviation and design intent, what all you require to conduct an HaZOP study? What is the data required to conduct an HaZOP study? Up to date process flow diagram is essentially vitally important to carry out an HaZOP study. You must also have a detailed process and instrumentation diagram in place, what we call PIDs. Equipment specification should be available to the HaZOP manager. Details of material inventory, mass and energy balances practiced in the process industry must be made available to the HaZOP team. HaZOP team actually consists of experts experienced in similar plants elsewhere, and they comprise of technical and safety professionals together. Now, what are the design objectives of an HaZOP study? HaZOP is generally done to identify the following: any perceived deviation from the intended design and operation should be the first catch of any HaZOP study. Then subsequently, after identifying the deviations from the design intent, it will result in certain causes for the deviations. So, you have to diagnose and find out what are those causes responsible for these deviations. The causes of those perceived deviations should be then resulting in consequences. One should identify and list the consequences resulting from these deviations. Then one has to examine whether any existing safeguards are present in the system, because these safeguards can prevent the causes and mitigate the consequences of the perceived deviation to a larger extent, because no plant in oil and gas industry is constructed or commissioned without any enough safeguard procedures. Therefore, one must give a due respect to the existing safeguard systems present in the scenario and see what are they can and how they can prevent the causes and mitigate the consequences. Based upon the presence of safeguards, based upon detailed analysis of the causes and consequences, HaZOP report also gives detailed recommendations of actions in the design as well as in operational modification, which results in improving safety and operability of the plant. Remember friends, the main focus of HaZOP study is not enhancing the commercial production of the plant at all. The main focus or objective of HaZOP study is to improve safety in design and operation. So, the entire focus of the thrust in an HaZOP study is only to improvise or to practice or to stringently follow the safety regulations and make the operations further safer. Now, the question asked is, where are the common areas where HaZOP study can be applied? The preliminary uses were essentially in chemical industry. I can quote an example from the site. The Flixborough disaster happened in 1974. Flixborough plant is a chemical plant located in UK which manufactures caprolactam, which is a chemical basically required to manufacture nylon. So there was a temporary bypass pipe which was ruptured during the scenario. Cyclohexane chemical at a temperature of 150 degrees Celsius leaked out, which caused explosion. More interestingly, about 20% of the plant's inventory went ablaze in few minutes after the pipe ruptured and the gas exploded. So it spread a vapor cloud for a radius diameter of about 200 meters around the plant, which caused a very high societal risk to the location where the plant was situated. Resulted further in explosion of an hydrogen production plant located in the nearby area. So this is very important. The societal responsibility of any process plant is also to safeguard the plants nearby. The second application where HaZOP study was applied immediately was to study the explosion of a rocket fuel plant located in Nevada, Las Vegas, United States. The plant was destroyed in few seconds. You can easily guess the reason for the accident. Windstorm destroyed the roof structure and the glass. The essential reason for this accident was an employee was using a welding torch which set fire, because the welding torch was situated in a location where the wind direction was not considered appropriately. Therefore, this actually torched off the roof structure and the glass, and the whole plant, which is a rocket fuel plant, got ablaze in a specific time interval. And that is the photograph which shows a thick smoke and blavy which is on the around the plant situation. So HaZOP studies essentially were applied to understand risks after the accident was happening. HaZOP study can also be done to avoid such accidents. So what is the first step in an HaZOP? The first step in a HaZOP study is to define the design intent of any given plant. Now the question is, what do you understand by design intent? Let us take some examples to understand design intent. Let us say you have a plant which does the following. It produces certain ton of chemical per year, it manufactures certain number of cars every year. The plant is a process plant which disposes certain volume of effluent every year. You have also a plant which produces certain barrel of oil every year, for example oil and gas industry. Now there are 4 examples shown here. One is chemical manufacturing plant, other is automobile manufacturing plant, other is effluent treatment plant, other is oil and gas industry which is a production or process plant. In all these plants, let us try to see what is the design intent. If you understand the design intent is the production capacity of the plant, then we are wrong. It is not the production capacity of the plant. It appears to be the main design intent of the plant, but equipments are generally designed and commissioned to achieve the desired production capacity. There is no doubt about that. In order to do so, each item, maybe the equipment, maybe the pumps, maybe the length of the pipe works, etc., are all designed carefully to achieve this design intent. Therefore, these equipments or these items will need to be consistently functioning in a particular manner to achieve the desired production capacity. So this is the design intent of the particular item. So the design intent is not the production capacity, but to check whether the equipments, the pipes, the pumps, the accessories are in place and working consistently to deliver the desired output, which all will lead to the desired production of the plant capacity. So it is not the machinery or the production capacity, it is actually checking the proper functioning of these equipments. Therefore HaZOP deals with production, in turn dealing with the equipments connected to the production. Now what do you understand by deviation in a design intent? Again let us take an example. Let us say for example a plant requires continuous circulation of a cooling water at a desired temperature. Let the temperature be x degrees Celsius and the volume of water required for cooling is about XXX liters an hour. Cooling of the process is done by heat exchanger. For effective functioning of the plant, effective working of heat exchanger is mandatory. Now what is the design intent here? The design intent here, as we understand from the previous slide, is effective working of the heat exchanger, because effective working of the heat exchanger alone can try to make the plant in a circulation of a cooling water. Now, what is the deviation? Water supplied for circulation, if it becomes more than x degree centigrade temperature, this would affect the production very seriously. Therefore, the deviation is the temperature of the circulating water. It means which is the process or the plant or the equipment or the machinery which maintains this temperature, that becomes the deviation. Note the difference between the deviation and the cause. For example, failure of a pump which will pumping this water would be a cause, not a deviation. So, the mechanical fault in a given process plant will not result in a deviation, can be a cause for the deviation. Now, one can ask a question, if I conduct an HaZOP study, what would be the advantages I gain when I do it for a new design? One can easily understand, if I do it for an existing process plant, I will know what are the faults present in the given system. If I do it for a new plant, what gain I will get from an HaZOP study. HaZOP supplements the design ideas with imaginative anticipation of deviations. These may be due to equipment malfunctioning or other operational errors which are not perceived by the design engineers. In the design of new plants, generally designers shall oversight few issues related to safety in the beginning. This may result in few errors. HaZOP fortunately highlights these errors in advance. HaZOP is therefore an opportunity to revisit and correct these errors before such changes become too expensive or impossible. HaZOP methodology is widely used to aid loss prevention, which is one of the main focus of safety in oil and gas industry. HaZOP is therefore a preferred tool of risk evaluation. It is very simple. The reasons are, it is easy to learn, it can be easily adapted to almost all operations in process industry, it is a common method in contamination problems rather than chemical exposure or explosions. Most importantly friends, there is no special level of academic qualification which is required to perform HaZOP analysis. Then what is the basic concept of HaZOP? The basic concept of HaZOP study is full description of the process. It examines the full description of the process thoroughly, and detailed documentation of this is the HaZOP report. It systematically questions every component or every part of the process industry to establish deviations from a given design intent. Once these deviations are identified, an assessment is made to estimate the consequences of such deviations. If considered necessary, actions are recommended to rectify the situation. Though the method is imaginative, but still it is systematic. Let us ask how. It is more than a checklist type of review. It encourages the team to identify the possible deviations, however unlikely they may seem to be. It helps to trace all possible deviations. HaZOP penetrates into greater depth of risk analysis of any process. HaZOP therefore, if applied onto the same type of plant repeatedly, will improve the process safety undoubtedly. The potential failures which were not noticed in the earlier study will be now re-examined by conducting this kind of HaZOP study repeatedly. Now, to conduct an HaZOP study, what would be the backbone of this kind of study? The backbone of the HaZOP study is essentially the keywords used in the study. There are two sets of keywords generally used in a HaZOP study. One is called primary, the other one is called secondary keywords. Primary keywords are generally focused on particular aspect of the design intent or an associated process condition, whereas secondary keywords suggest possible deviation when combined with the primary keywords. As I said, design intent and deviation are essential two functions of an HaZOP report. Design intent is focused by the primary keyword and deviation is addressed by the secondary keyword. So, design intent and deviation together should be made to understand for a process manager. Therefore, HaZOP report revolves around two set of keywords, not independently but combined together will give a meaning in an HaZOP report. HaZOP therefore revolves around the effective use of these keywords. Therefore, it is important to know what are the typical keywords of primary and secondary in order, what is the meaning of these keywords and how to use them. If at all we have to write an HaZOP report. Let us quickly see what are primary keywords. Primary keywords reflect both the process design intent and the operational design intent of any aspect of the plant. There are some examples listed here: flow, temperature, pressure, level, separate, composition, react, mix, reduce, absorb, corrode, erode, etc. So, these are some examples of primary keywords. These keywords sometimes may be confusing. Let us take an example. Let us take the word corrode, which is one of the important primary keyword. Now, primary keyword addresses design intent. If I say corrode is a primary keyword, one may get confused, is corrosion a design intent? Obviously, in any given plant, corrosion should not occur. That cannot be a design intent, because most plants are designed with a design intent that corrosion should not occur during certain lifespan of the structure. Even it is expected to occur, there should be some corrective means to reduce this corrosion rate. An increased corrosion rate would therefore result in deviation from the design intent. Therefore, corrode is a word which activates deviation from the design intent. Some more primary keywords related to process shall be isolate, drain, vent, purge, inspect, maintain, startup, shutdown, etc. Again, there is a word here which can cause confusion, because one of the primary keyword indicated here is shutdown. Now, how shutdown can be a design intent? It is a design intent in certain cases where if you really wanted to recalibrate or replace the pressure gauge, you have to isolate certain segment of the plant. Therefore, you have got to shut down certain segment of the process plant, so that recalibration can become very important, and this has got to be carried out. Therefore, even such keywords can also indicate design intents for a given process plant. Now, let us see what are the list of secondary keywords. Secondary keywords, when applied in conjunction with primary, suggest potential deviations. There are some examples. Let us say no is a secondary keyword, less, more, reverse, etc. Now, the design intent does not occur. For example, flow is a primary keyword, no is a secondary keyword. So, if we combine these two, then one can say there is no flow which causes a deviation. For example, let us say less. Pressure is a primary keyword, less is a secondary keyword. If we use both of them together in conjunction, less pressure is an indication for a cause, it can result in some consequence. Similarly, all these secondary keywords will have a specific meaning when they are addressed along with the primary keyword. For example, other words like also, other, fluctuation, early can be some of the secondary keywords. Please note that all the combination of primary and secondary will not work out. For example, temperature no, pressure reverse will have no meaning, because temperature no means there is no process at all, pressure reverse means there is no pressure flow in the forward direction at all. So, all combinations of primary and secondary cannot be considered for writing a HaZOP report. And then the question comes, which combination should be used and when? So, results of our study essentially is pattern of recording in a desired format. Terms are used in a HaZOP report. Format of the report is shown below. The first column shows deviation, the second column shows causes, the third column shows consequences, the fourth column shows safeguard, and the fifth column shows recommended action. Now, one may ask me a question, sir, HaZOP report deals with primary and secondary keywords. Primary keywords dictate the design intent, secondary keywords dictate the deviations. Now, in this table I could see deviation, but where are the design intent? That is very interesting. I will take an example and show you how design intent is incorporated as a primary keyword in a HaZOP report. Let us take an example here. There is a dosing tank T1 which has to supply some chemical mixture to the container V1 and the container also receives chemical from a mixture as a third line. Now, the dosing tank T1 has got two components mixed together and these components can be even containing floating suspended particles. Therefore, I use a strainer S1 to filter the suspended particles and of course, I got to pump this chemical to the container V1, therefore, I require a pump P1. Now, the components identified here are the dosing tank T1, the strainer S1, it is nothing but a filter, the pump P1, the mixture and the container V1. Let us quickly see this as an example problem. The deviation in this particular problem taken for example is flow no. For example, flow is a primary keyword which indicates the design intent. The design intent in this problem is flow because I need to have a flow along the line to maintain a specific composition of mixture at the container V1. If there is no flow occurring in the line which does not receive any chemical from the dosing tank T1, then it can cause serious deviations, result in consequences and that can cause accidents. Therefore, flow no is a combination of primary and secondary keyword which now describes the design intent and the deviation in a given process plan as seen here. Potential causes that would result in deviation can be the strainer S1 can get blocked or choked off. It can be due to the suspended impurities or the dissolved impurities present in the dosing tank T1. The filter present in strainer S1 may be blocked completely, therefore, the flow in the pipeline causing the strainer S1 may not be there, or the desired flow in the pipeline segment here may not appear because the strainer S1 is blocking the flow from the line crossing the strainer. When there is no desired flow on the pipeline, pump will run empty and pump will not require to pump the remaining quantity required for the chemical V1 from the pump P1. Therefore, strainer S1 blockage due to impurities in the dosing tank T1 might cause a condition which is no flow, which is one of the deviations in a given plant. Now, let us see the consequences if there is no flow. The consequence can be the loss of dosing results in incomplete separation in the tank V1. The additional cause can be cavitation in the pump P1 because the pump does not require or receive required amount of quantity of water or the flow after the strainer S1. Therefore, this may result in possible damage to the pump if it is prolonged. Now, how will you record the consequences? Consequences, if they are recorded in a HaZOP report, should be explicit in recording the consequences. Do not assume that the reader at some time later date will be fully aware of the significance of the statement. For example, do not make statements as no dosing chemical to the mixture. It is better always elaborate the statements with full explanations. When assessing consequences, kindly do not take any credit for protective system or instruments that are already in place. For example, in a design there can be already safeguards. Do not take the credit of these safeguards and do not mention them in the consequences. I can show an example. The team identified a cause as flow or no in a given system as being spurious closure of an actuated valve. It is noticed that the valve position indication is displayed in the central control room. One can imagine that the central control room has an indication of the closure position of the valve. That is a safeguard in the design. Do not try to assume that since this is available, consequences cannot occur. Also, there can be an alarm existing control panel which will indicate the closure of this valve. These are all already present in the design system. Do not try to take an advantage of this and do not try to override these while writing the consequences in a given report. Because the spurious closure of the valve could result in increase in pressure in the upstream line which leads to serious deviations. It can result in fire. If not rectified within few minutes, for example, it can cause explosion. Therefore, do not credit for protective systems or instruments that are already in place which are included in the design in your consequences column of the report. Let us come to the safeguard column. of an HaZOP report. Any existing protective devices that either prevent the cause or safeguard the adverse consequences should be recorded in this column. Safeguards need not be restricted to hardware alone. Even periodic inspection, maintenance schedule can also be a part of safeguard column given in HaZOP report. Be assured that these inspections must be carried out if you really take an advantage of these as a safeguard column in a HaZOP report. Let us come to the recommended action column. That is the last column in an HaZOP report. If a credible cause results in negative consequences, it must be decided whether some action should be taken or not. Now, recommended actions are generally slated only depending upon accepted level of risk in a given plant, which is highly subjective. It is therefore become important that protective measures are kept adequate in a given system. If it is so, then you can simply say no action need to be taken. This can also be recorded if the action column is appropriately done in the HaZOP report. Action falls in two groups: action that remove the causes, action that mitigate or eliminate the consequences. First type is mostly preferred when you record in HaZOP reports, but not always possible when dealing with equipment malfunctioning, therefore it is not required. Let us see for this example what are the possible actions that are required for a good problem. It ensures that impurities cannot get through T1. So, fit a strainer in the rope tanker itself which supplies chemical to the strainer tank T1. Consider carefully whether strainer is required in the suction to the pump. Whether you can put the strainer here or not, you have to very carefully design the system for its layout. Examine whether it is necessary that no such matters should enter V1. For example, if the container V1 can allow the suspended impurities, do not put strainer S1 in this location because strainer S1 can cause no flow to this line. Fit a duplex strainer with a regular schedule to change over and clean the standby unit appropriately. Now, let us discuss few important points that are to be carried out or remembered while writing an HaZOP report. Do not automatically opt for engineered solutions. Adding additional instruments, alarms, trip off switches, etc. is not a good recommendation for an HaZOP report. Give due respects and regards to the reliability of such devices and their potential for spurious operation. In addition, this may also result in increased operation cost because the maintenance schedule, regular calibration all will be affected if you recommend additional instruments in a given PID. Consider also the level of training imparted to these people who are experienced to operate these kind of alarm types and instruments. Please understand, sophisticated protective devices are dangerous if operators are not trained how to use them. Therefore, maintenance also becomes equally complicated. So, advocating additional instruments, alarm types, trip off switches should not be the only solution in the recommended action of an HaZOP report. Let us quickly see how an HaZOP flowchart looks like. Select a section of the plant, have all relevant primary keywords in place. If the keywords are not available, select a proper primary keyword which is applicable to the process plant. Have all relevant secondary keywords in place because they will talk about the deviations in a given process. If they are not available, select a relevant secondary keyword. Then identify what are the causes arising from the deviations. If not, they are listed. If you have listed them, then record the new cause. If they are not listed, go back to the secondary keyword, identify the causes from the deviations and keep on recording them. Once you record the new causes, try to check whether the consequences associated with these causes are available. If they are not available, go back to the cause column again, try to check the deviation, list the consequences. If they are available, record the consequences and record the safeguards present in the system. If you are not able to identify them, then go back to the process again, check for the safeguards, record them, the deviations, then the causes, then the consequences. If they are agreed upon the actions already taken, then check with the required level, record them in the agreed action and get back to this for different segments and continue and complete the entire report. While recording the HaZOP report, you got two components in recording. One is called full recording, other is called recording by exception. In earlier HaZOP reports made in the 80s, only potential deviations with negative consequences were generally recorded because they were used for internal use only. Also, their reports were mostly handwritten. Therefore, to reduce the volume of the report and the time in reading the report, only potential deviations were reported. Such methodology was called as recording by exception. In this method, it is assumed that anything that is not included is deemed to be satisfactory, whereas in the present scenario people follow full recording. Full recording is followed because nowadays HaZOP reports are purely electronic in nature. You can generate these reports automatically using software. Each keyword is clearly stated as applied to the problem. Even statements like no cause could be identified or no consequences arise from the cause recorded are also seen in such statements. This is called full recording. Full recording reports show to outside parties that a rigorous study has been undertaken. It also produces comprehensive document. This can assist in speedy assessment of safety and operability of the plan at a later stage. With computer methods in practice, full recording has become more efficient and easy in these days. Some macro keywords shall also be used in recording for full records. Examples can be no potential causes identified, no significant negative consequences identified, no action required. There are some pseudo secondary keywords which are also available. All, remainder, these are used in the following situations. Pseudo secondary keywords are used for a primary keyword where no appropriate secondary keyword is found suitable. For example, let us take an example of flow as a primary keyword. Some combinations with primary keyword which will have credible causes can be no flow, can be reverse flow. Some combinations will have no consequence or cause, which is called less flow, more flow and other flow, etc. So, they can be pseudo keywords. Therefore, flow remainder can be used as a macro word. Instead of writing flow less, flow more and flow other, the remainder term will cover all the secondary keywords of less, more and other. The other consequences or deviations of no and reverse are explicitly reported. Therefore, remainder can be an example of a macro keyword which substitutes less, more and other. After exploring all possible combinations of primary and secondary keywords, no potential deviations could be identified. In that case, you simply say flow all can be used. So, all becomes a macro word which can substitute all deviations that can occur from the design intent. So, use of potential pseudo keywords greatly improves readability because this eliminates countless repetitive entries in a HaZOP report. HaZOP report therefore should clearly mention the list of secondary keywords used in the study in the beginning of the report itself. So, in this example and in this lecture we have studied how to do HaZOP evaluation, how to document an HaZOP report, what is a design intent, what are deviations, what are causes which result from the deviation, what would be the consequences, what would be the safeguards present in a given system, how to record them and advocate recommended actions in a given process plan. So, HaZOP report essentially circumscribes only safety in a given plant. HaZOP can be done in an operational stage which is called HaZOP report, can also be done in design stage which is called hazard report, which is HAZ ID, which identifies the hazards in the design stage itself. Thank you very much.